Hey guys, today we're going to be talking about rewriting formulas. Now, rewriting formulas is an essential part of algebra. In order to rewrite a formula, what we're going to do is we're going to isolate another variable in the formula on one side of the equal sign. And that's going to require us to move some numbers and variables across the equal sign. And when we move them across the equal sign, we want to use our inverse operations. Now, you guys have learned PEMDAS, that's the order of operations. And when we move things around the equal sign, we're actually going to use inverse operations. So we'll go in the inverse order of PEMDAS. So take this one for example. If I have my area formula for a circle, and I want to rewrite this in terms of r, the radius, that means I want to isolate r. So I'm going to start by moving pi over to the other side of the equal sign. Since pi is attached by multiplication, that means I divide both sides by pi. Now I have a over pi is equal to the radius squared. My final step is to get the r by itself, and to undo a square, I need to take the square root. So in the end, I'll have the radius as the square root of the area divided by pi. Now this is the formula written in terms of r, and these formulas here, r is equal to the square root of a over pi, and a equals pi r squared, are known as what's called equivalent formulas. All right, let's take a look at another example. We know that the period p of a pendulum and the time in seconds that it takes for the pendulum to make one complete swing back and forth, and is calculated using p, that period, is equal to 2 pi times the square root of L divided by G, where L is the length of the pendulum and G is the acceleration due to gravity. And that's a constant. It's 9.8 meters per second squared. So our first task is to solve this formula for L. In other words, we want to rewrite this formula here in terms of L. Get L on one side of the equal sign and everything else on the other. So let's start off by rewriting our formula. Now, we see that 2 pi is attached to that square root of L divided by G. I want to start off by dividing both sides by 2 pi. Now, I can get rid of that square root symbol by squaring both sides. These are inverse operations of each other. So now I'm left with L divided by G is equal to p over 2 pi quantity squared. Now, my final step is to get L by itself. I see L is being divided by G, so the inverse operation of division is multiplication. So I need to multiply both sides by G. Now I have a formula here that's written in terms of L. All right, in part B, I want to find the approximate length of a pendulum whose period is 1 minute. Now, remember, this formula here is given in terms of seconds, so I have to convert 1 minute to 60 seconds. And I'm going to place that in here for my value as the value of my variable for p. So I get L is equal to 60 over 2 pi quantity squared times G, and remember my G value is 9.8. I should end up with 893.65 meters. All right, let's dive into example 2. Because the density of air consumed by scuba divers increases as they dive deeper, they consume more air the deeper they dive. This formula, T equals 30S divided by D plus 30, is used by some scuba divers to calculate the amount of air they'll need if S is the amount of air in minutes they have at the surface. So we want to solve this formula for D in terms of T and S. So that means I want to isolate D. All right, well, let's start off by rewriting our formula. We see that T is equal to 30S divided by D plus 30. Now, D is what I want to get by itself, and I can see that it's in the denominator right now. So I'm going to put parentheses around the D plus 30. This is an entire term. So because it's in the denominator, I can simply multiply both sides by the quantity D plus 30. And when I do that, they'll cancel each other out on the right-hand side, and I'll have D plus 30 times T is equal to 30S. Now, I see that these are two terms. If I distribute that, I'm really making more work for myself. So what I'm going to do is just divide both sides by T. That will get rid of it on the left-hand side there, and I'll be left with d plus 30 is equal to 30s over t. And finally, in order to get d by itself, I'm simply going to subtract 30 from both sides. Now, my equation here, or my formula, is d is equal to 30s divided by t minus 30. And here it is rewritten in terms of d. All right, let's take a look at example 3. It says a certain ancient pyramid has a volume of x cubic meters. We know that each side of its base is 230 meters. So keep that in mind. It's a square pyramid, if you remember back to geometry, in which the base edge is 231. So there's our base edge. If we draw our pyramid up, there's our beautiful looking pyramid. All right, we know that the volume of a pyramid is the area of the base times the height divided by 3. We want to solve this or rewrite this formula in terms of h. So that means we got to isolate h, get h by itself. So I know right now that volume is equal to the area of the base times the height divided by 3. So let's start by multiplying both sides by 3. That cancels it on the right hand side, and I have the area of the base times the height is equal to 3v. And my final step, I now need to divide off by the area of the base in order to get h by itself. So I now have the height of this pyramid is equal to 3 times the volume divided by the area of the base. All right, and that's perfect because that's what I want to use for my second part of this question. It says assume that the pyramid has a volume of 2,614,689 cubic meters. What is the height? So I'm going to substitute in height, I'm going to substitute in my volume. My height is equal to 3 times that volume of 2,614,689, all divided by the area of the base. Now, the area of that base is a square, and that square has edge lengths 231 by 231. So that means I have to take 231 and multiply it by itself, or square it. And that's going to give me the number 56,361. All right, so in all, I'll have a height of 3 times that 2,614,689 divided by 53,361, and that's going to result in a height of 147 meters.